Okay, today we have a case determining statistical evidence. On the prosecution side, we have Mr. McChill, who is prosecuting Chuck, who is representing himself for the charge of failing AP statistics. Do we have any opening statements from either side?
Yes, Your Honor. Now, before we get into the shenanigans of the test, I think we should decide on an alpha level. Now, I'm a pretty simple guy, you know? I think an alpha level of 0.05 should do the trick.
Actually, I think the alpha level should be 0.01. JAR is just too big of a danger to justice everywhere. The probability of a type 1 error is just too high. We'd be putting ourselves at risk.
Chuck, I think your alleged stats allergy is getting to your head. Your Honor, a 0.05 alpha level is not a threat to justice everywhere. Oh yes, the issue of getting a type 1 error is prevalent. The idea of power being low is much more severe. Your Honor, if Chuck were passing the class, yes, 0.01 alpha level would be fine. However, if he were not passing the class, as I believe, then we need more power to be able to rightfully convict him. A 0.05 alpha level balances both the necessary power and the low risk of getting a type 1 error.
Objection, argumentative.
Overruled. As judge, I declare the most appropriate alpha level to use be 0.05.
Now, as for the type of test, I was thinking, what about a good old-fashioned t-test for mute?
Jarhead. What are you even trying to achieve here? Have you even considered the conditions? Do you even know what parameters we're trying to seek here?
Chuck, sit down and let McChill finish.
As I was saying, I think that we should do a t-test for mu, with mu being defined as the true mean test score average for all AP Stat students and all the chapter tests. What we're trying to find convincing evidence for is that good old Chuck's average test score is significantly lower than the class average, putting him in danger of failing the class at the 0.05 significance level.
Jarmelius, did you even consider if a t-test is possible? I mean, we've only done 12 chapter tests, so even if we conducted a census, the normal condition just wouldn't be met. And how would you even randomize that sample? The 10% condition for a random sample with a population size of 12? Come on, Jar Spinoza, don't be that dense.
10% condition is not violated in this case. If we were to take a random sample of size n equals 5 from the population of all standardized test scores across the 12 chapter tests for all stats periods, you would find that the 10% condition is not violated, nor is the randomization condition.
But what about the normal condition?
Chuck, check your pocket if you would.
Jarl, did you sneak a TI 84 Plus colored edition in my pocket?
Just check it.
This calculator doesn't even have stats in it. If you're trying to prove that I have a stats allergy, this simple trick just won't work.
Meet my buddy, Huel. Chuck, while you were walking down the hall, he planted something in your hoodie. He is on the witness list, and what he says can be used against you in court.
That is all true. Wait, what? What is this?
Now, you are right that normal condition isn't met. However, what you need to begin to consider is that the original population is approximately normal because those test scores are standardized. Now, and you didn't even begin to think about using a box plot because if there's no strong skewness or outliers, the normal condition is still met.
I am not failing my classes. I would never score so lowly in a class. I've done well in all my other classes. I mean, look at him. He's always been this way. He even got that idiot to play into a scheme. This is bad. This chicanery.
Chuck, McChill, calm down.
No, I will not calm down.
You haven't even finished my argument. Using degrees of freedom of 4, assuming that you perform about the same as everybody else across all 12 chapter tests, we find the probability of getting a test average of 27 out of 100 is approximately 0. Therefore,
Mr. Chuck,
we have convincing evidence that you are getting the class.
No.